All right, so we're starting off with the half sheet, the paper that you got yesterday. It folds in half, makes a little booklet. It looks like it says maximize the area of an animal pen. Yes?
Yes.
Okay. If you weren't here yesterday, I went ahead and left that green basket on top of the box so you can just grab it and go. So if you weren't here yesterday, it's still on top. And you can just grab it. We're gonna title it. It's gonna be this is 1.1G modeling quadratics. Quadratics. Okay. Part 1. All right. Now, how many of you remember in geometry, what were your main things that you talked about?
I don't even remember.
Like, what main things you calculated?
We did a lot of trigonometry.
Oh, towards the end, I did a lot of trigonometry. I heard the word shapes. Did we say shapes? That was the word I was looking for.
Really?
Yes, we talked about a lot of shapes, right? And with those shapes, you found the what? You calculated their what? Area, right? Okay, that's what we're doing. We're using those knowledge of calculating area, but now we're taking it from a geometry perspective to a algebra function perspective. Okay, so that's what we're talking about here. All right. A farmer has 2,400 feet of fencing and needs to build a rectangular pen to fence in her animals for grazing. The farmer hires you to help her determine the dimensions of the pen and closing the greatest area that can be constructed with available fencing. Okay, so your job is to come up with if you can come up with the dimensions. Now let's talk about what 2,400 represents. In terms of geometry, 2,400 feet represents my what?
Your width.
Mm-mm.
The base.
My perimeter.
Oh, yeah, that's what I meant.
2,400 feet equals my perimeter.
I was trying to get there.
Right? Your perimeter of a rectangle is 2 lengths plus 2 widths. Agreed? We remember that? Yeah, because 2 sides. All right. So what I want you to think of for a moment is I want you to come up with 3 designs that you're going to submit to Farmer Joe here. With the dimensions using only 2,400. Okay, so I'm going to give you about, let's say, 90 seconds to come up with 3 designs. What designs can Farmer Joe get from you?
Can you write it down?
Yeah, in box 1. Sketch. You can either sketch it out, write the dimensions, whichever one you feel most comfortable doing. Yes, each has to be different. Each design has to be different. All right, someone give me one of your.
700 for the 500.
So we have a 700 by 500. Cool. All right. Option 1. Another one. How much?
650 for on top
Uh-huh.
and 550 on the side.
Okay, so we have a 650 going like this.
Yep.
And we have a 550.
I have a 600 all the way around.
Okay. Uh-oh, that's supposed to be a 5. You see that. And we have a 600. We have a square. Randy did a square.
That's the place my people live.
Guys, I feel like that's a fairly decent square for me.
And it should be
All right. But do we see
where we're coming from.
where we're coming from?
Yeah.
What do you notice between your width and your length of each one of these?
It's mine. I got it.
They what? They all equal the same. And what is that value?
Area.
No, just looking at the width and the length of each one of these, what do they all equal? 1,200, right? So your width plus your length has to equal 1,200. Does that make sense?
Yeah.
So there's all these possibilities of getting that value. Does that make sense?
Yeah.
Because there's so many ways to make the combination of 1,200. Okay, because of that, there's so many combinations and there's so many options. That's a key to mathematicians. Like, oh my gosh, there's a function. There's a function out there that would make this way easier for me. Let me find that function. Okay, that's what it tells me, is because it's so many possibilities. So what we're gonna do is we're gonna create a 3-column table with the width, the length, and the area, but we're using our calculator to do so, okay? So we're gonna be doing it in the calculator. So we're gonna be using our TI 84. We're gonna first go to stat, and then we're gonna go to 1 for edit, right? In there, we're gonna have 3 columns. The things that we're focusing on are width, length, and area. So our width is gonna be our L1. Our length is gonna be our L2. And our area is gonna be our L3. Are we okay with that? Okay, so area equals width times length. Therefore, L3 equals L1 times L2. Yes? All right, so let's go to my handy dandy calculator. I'm going to reset my calculator by pressing second plus 712. Second plus 712. Second plus 712. Yeah, a dot, a multiplication dot. I'm going to go, where am I going? Stat, edit. And I'm going to put in those values, right? So I'm going to put in whatever you guys told me for width and length, okay? My goal is to put in hopefully all that everyone has said, okay? So from our first ones, we had the 500 by 700, right? Yes, or 700 by 500, either way. And then we had 650 by, what was it, 550? We had Randy's 600 by 600. What was yours? 925 by what? 275. Okay, some more? What are other dimensions you guys had? We had 1000 and a 200. Okay, other ones. Another. I got 600 by 600. What were the other things you wrote down on your paper? 900 by 300. Okay, we have a 900 by 300. I know in this class of 20-some people that these aren't all the possibilities y'all wrote down. We had an 800 by 400. There we go. What else did we have? Y'all all wrote the exact same thing down?
Yeah.
Really? 1100 by what? 100? You said 100? What am I? Clear. Yes, 1100 by 100. And again, the key thing is my length and my width have to equal what? 1200, right? Okay. Any other ones that y'all had written down? Yes, what'd you have? We're just collecting the data.
I think we got them all.
You do 850 by 350.
I have 850 by 350. We're just collecting what everyone did so that everyone's data is included. Okay. What was it? 850 by 350. Okay, remember for calculator, if you never practice it along with us, when it gets to the quizzes and tests, you're going to epically struggle.
Yeah, I don't have experience.
If you don't practice it, you're going to... All right. Are we good? Did we get the rules? We get the pattern? Everyone understands the length plus the width has to equal 1200. Okay, now we're going to find our area. Area equals width times length. So L3 is going to equal L1 times L2. I'm going to go to L3 and I'm going to press second 1 times second 2. Do we see that?
This is magic.
And it does it. Oh my gosh. It thinks for me. Crazy. Who knew?
It's like Christmas.
All right. Before I press enter, do we all see what we put in? L1 times L2. In order to put in the rule, you have to be on the column. Not in the column, but on the top of it. Okay. So I press enter and it says boom, 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 boom. Here are your areas. Yes?
Yeah.
All right. So it says share your class values. Here are our class values. No. All right, are we good sharing our class values? Yes. Now we're gonna find our regression model that represents this, okay? So what is the equation that's gonna populate this every single time? If I tell you the width, can you tell me what the area is gonna be, right? That's how you run a business. What is the fastest way I can tell someone how much it's gonna cost or how long it's gonna take or what I can do for them, right? That's the purpose of a function.
Just write the LD
On which part?
on 3.
Yeah, if you want, if you're okay with just saying we did in the calculator, I just put a check because I don't feel like writing. Huh? You can just put as much as you want on your thing. All right, here we go. So now we're going to talk about finding our regression model. So in here, we're not doing it in Desmos. On here, remind you how to do it on Desmos, right? The thing is, with Desmos, you would have to type it and find your own area. It will not calculate just like we did with L3. Does that make sense? So when we did it, the calculator did its own L3 for us, right? On Desmos, you would have to actually do your own L3 each time.
Yeah, I don't like.
Which is why I didn't want to waste our time doing Desmos. Does that make sense?
So when I do
Okay.
part 2.
All right, no, we're just going to do it in calculator. So this is how you do it in Desmos, just FYI. But how do we find a regression in the calculator?
So you will have to go. Oh wait, isn't this what we just did?
Stat what?
That and one.
Stat calc. If I'm looking for regression in TI-84, I'm going to go to stat. And then I'm going to go to calc. And if I'm looking for a quadratic regression, what number is that going to be? Quadratic is 5. So I'm going to go stat calc and I'm going to go to 5 to quad reg. That stands for quad regression. Do we see that? Now, this is the thing. We have to tell it what it wants us to calculate. We are comparing our width to our area. So when we are defining this, our x's are going to be our L1 because that's what our width was, right? But our y's are going to be our L3 because that's what our area is. So we have to change the value of our y. My little questionable W. We can fix her. We can fix her. All right, are we ready to do it? Right here? Yes, that's 5. Our y has to be L3 because that's where our area is. Okay, so the data that you're comparing is what you have to make it. So if I'm comparing width to area, I have to make sure that I'm using our column that we set for our width and our column that we set for our area. Does that make sense? All right, so I'm going to pull up my handy dandy calculator. I'm going to follow these steps. So I'm going to stat, calc, and we want the ln regression. Quad regression. Yes. Our X list is our L1, but our Y list needs to be our what? So I'm just going to press second 3 and change it. And then calculate. And it's going to tell me my equation. Okay. There you go. Perfect. So again, we went stat, calc, 5. So we went stat, calc, 5. We changed our X list was good, but our Y list needed to be changed. I changed it by pressing second 3. Now it's our L3 because we're comparing our width to our area. If I know the width, can I know the area I can create? Okay. I would have to look. I don't know what you did, sir. You could put 0 if you want. All right. So now it tells me here's your quadratic regression. Your A, which is with your x squared term, is -1. Your B is 1200, which is with your x term. And your constant is 0. Is it necessary to write 0? No, but you can if it helps your heart. So it says, what is our model for this? So our model would be y equals -1x squared plus 1200x. Okay, yes.
Absolutely.
All right, so now we're going to talk about graphing and using it to find our maximum. So I have an equation. Can I now create a graph because I have an equation? Yes. The biggest thing that I'm asked, Miss, how do I put a graph in the calculator? Guys, y equals is how we graph. That's going to lead you to a graph, okay? So in order to put a graph in the calculator, you have to go to y equals. Okay? From y equals, you're going to have to adjust your window. You have to be comfortable with adjusting until you see what you need to see. Does that make sense? All right, so I'm going to go to y equals. I'm putting in my equation. What is my equation? Negative 1x squared plus 1200x. Our equation that we got from above, right? Okay, I'm going to press graph and not see it. I'm going to give you 90 seconds to see if you can fix your window to see your graph. And then we will go over how to do it. Okay, I'll be walking around to assist people, but notice how when I go to graph, I can't see anything. It's thinking, you see the little thing is thinking, and it says here, this is all I'm going to show you. That doesn't show me a max or a min. So work on adjusting your window so that you can see it. So me, logic, I just go look at my table. So when I looked at my table values here, I was like, oh, these are some pretty big numbers that I had in here, right? My X's are pretty large and my Y's are very large. So then I'm like, okay, on my window, I have only positive X's. So I'm going to start at 0. My max was all the way up to 1200 because that's what the sum of them had to equal, right?
Yeah.
So I'm going to go over a little bit. I don't want to have a whole bunch of little lines, so I'm going to count by 100. On my min, did we have any negative Y's? No. But when I looked at my table, my numbers were really large, right, for the area. So I'm just going to put in 500,000. And we're going to count by 1,000. Okay? I used a little bit of math sense and a little bit of common sense to come to a conclusion so that I'm not zooming in and out too much. Okay? If I have data that I'm analyzing, I can use that data to determine what is going to be the best window for my graph. So then when I go to graph,
Has he changed your scale?
I did.
I haven't changed it.
Because I don't want to see the little. It's more like a
What did you
aesthetic
change
thing.
it to? Oh.
100 and 1,000. My scale, 100 on the x-axis, and then 1,000 on the y-axis.
For now, I'm.
Do you need me to go back to the window settings? We can tell that there's a maximum, and the question is asking, what is your greatest area, right? So the greatest area tells us that we need to find what is our maximum value. You see that? So our vertex, exactly. We need to find our vertex. In order to do that, we're going to press second, and we're going to press trace. And that's going to take us to the back. And look, it even says it. What do we need to find? Maximum. Do we see where it says maximum?
Yeah.
Yes. So what did we press? Let's go back again. Second and trace. And now we can go to maximum. Okay.
It's 650.
All right. So this tells you to go left bound. I call this little guy I've been calling the guy my spider since 8th grade. So you see my little spider, my little calculator spider? He tells me that I need to move to the left. You see where it says left bound? So I'm going to move to the left of my vertex and press enter. He then tells me I need to do what? Move to the right of my vertex. So I'm going to move to the right of my vertex. And move to the right, and I'm going to press enter. And it's asking, do you think your max and min is somewhere between here?
Yeah.
Yeah. So yes, tell me what it is. I press enter. And it's going to say, all right, here it is. Approximately at 600, basically, right? 599.99 or 600, blah, blah, blah. So basically my max width is at 600. If my width is 600, then my area is gonna be 360,000, right? That's my maximum area that can create from the 600. That's how you answer this part of the question. Okay, on decimals, I'm not gonna lie to you, finding the max and min is a little bit easier. Cause you just gotta zoom out and then click.
Well, that's not us. We don't go to you.
Yeah, you do.
No, we're better than that. Yeah.
It is easier on decimals, but I feel like you don't get as much pride in value. You don't get to play with spider, okay?
I like spiders.
All right, was that terrible?
Yes.
What made it terrible?
This class.
So answer the question, what is the greatest area? 360,000 square feet, right? So that's what you're writing in there. The greatest area is 360,000 square feet. Okay,
This shows what you put in your copy.
protein.
We have less than 5 minutes.
So our max area equals 360,000. It's feet, right? Square feet.
Square feet. Square.
Feet squared, square feet. Okay, the next part is saying, how can you write your equation in vertex form? Well, we can't, because we know our vertex, right? We know, so if you took your notes like you were supposed to 2 days ago, you know that your H and K is your vertex. So for this problem, our vertex is at 600, comma, 360,000. Agree? Your A comes from your regression model. And what did we get for our A in our regression model? -1. Do I have everything I need to write that equation? Yes. So in vertex form, we have y equals -1 times x minus our h, which is 600, plus our k, which is 360,000. I don't know why I wrote a k. That's lazy.
Yeah, we don't be lazy around here, so. I'll be lazy. I've been writing K the whole time. We walk construction on it.
Well, it's hard to write that when it's like k is part of your vertex, so it's like too many thingies.
Clean up. Clean up, everybody clean up.
Okay, so this also corresponds to here, because if I can write it in vertex form, then I know the
Wait,
vertex. Okay, just recapping, you're either gonna have a max vertex or a min. It's on the printer. Sorry. Or you're gonna have a minimum vertex. Okay. All right, so we did not get to the student practice.
It's okay. Do we have to do the student practice by ourselves?
It'll be your due now probably on Monday.
Okay, so just do it. On the weekend. What is the test next week?